Deadly space missions, the risks of space exploration. It's a cosmic tapestry woven with threads of human ingenuity, bravery, and an insatiable thirst for discovery. But let's be clear, venturing beyond Earth's embrace is not for the faint of heart. It's a high-stakes endeavor where the margin for error is razor-thin and the consequences of failure can be catastrophic. Throughout history, we've witnessed moments of triumph in space exploration, moments that have pushed the boundaries of human potential. But we've also experienced profound tragedies, stark reminders of the inherent risks associated with pushing the limits of technology and human endurance. In this series, we're going to delve into some of the most dangerous and tragic space missions ever undertaken. We'll explore the events leading up to these disasters, the lives lost, and the crucial lessons learned that have shaped the future of space exploration. The year was 1967. America was locked in a fierce space race with the Soviet Union, determined to fulfill President Kennedy's goal of landing a man on the moon before the decade's end. But on January 27th, tragedy struck on the launch pad. Apollo 1, the first crewed mission of the Apollo program, was undergoing a routine pre-launch test. Astronauts Gus Grissom, Ed White, and Roger Chaffee were strapped into the command module, a confined space filled with pure oxygen. Suddenly, a fire ignited inside the module. The exact cause remains uncertain, but an electrical spark in that oxygen-rich environment turned the spacecraft into an inferno in a matter of seconds. The intensity of the fire and the rapid spread of flames made escape impossible. The crew perished within minutes. The Apollo 1 fire was a devastating blow to NASA and the nation. It exposed critical flaws in the spacecraft's design and safety protocols. However, from the ashes of tragedy rose a determination to learn and improve. NASA embarked on a comprehensive review of the Apollo program, leading to significant design changes, improved safety procedures, and a renewed focus on crew safety. In 1971, the Soviet Union achieved a historic milestone with the launch of Salyut 1, the world's first space station. Aboard Soyuz 11, cosmonauts Georgy Dobrovolsky, Viktor Patsayev, and Vladislav Volkov docked with Salyut 1, spending 23 days conducting scientific experiments. Their mission was hailed as a triumph for the Soviet space program, but their return journey would transform triumph into tragedy. During the descent, as Soyuz 11 separated from its orbital module, a critical ventilation valve malfunctioned. This seemingly small valve, designed to equalize pressure during re-entry, failed to close properly. As a result, the spacecraft's atmosphere rapidly vented into the vacuum of space. The cosmonauts without spacesuits were exposed to a swift and silent decompression. They lost consciousness within seconds and perished due to the lack of oxygen. When the recovery team opened the capsule, they found the cosmonauts still strapped in their seats, appearing to be asleep. The Soyuz 11 tragedy sent shockwaves through the global space community. It highlighted the unforgiving nature of space and the importance of redundancy in spacecraft life support systems. January 28, 1986, dawned bright and clear in Florida, but the promise of a routine space shuttle launch soon turned into an unimaginable nightmare. Millions around the world watched in horror as the Space Shuttle Challenger disintegrated 73 seconds after liftoff. On board were 7 astronauts, including Krista McAuliffe, a schoolteacher chosen to be the first civilian in space. Her presence had captured the imagination of the nation, inspiring countless children to dream of reaching for the stars. The cause of the disaster was traced back to a failure in one of the solid rocket boosters. O-rings, designed to seal joints in the booster, had become brittle in the unusually cold temperatures that morning. As the shuttle ascended, hot gases escaped through a breach in the booster, igniting the massive fuel tank and causing the shuttle to break apart under the immense aerodynamic forces. The Challenger disaster sent shockwaves through the world, shattering the illusion of routine spaceflight. It led to a grounding of the shuttle program for nearly 3 years, as NASA grappled with the technical and organizational failings that contributed to the tragedy. 17 years after Challenger, another space shuttle tragedy unfolded, casting a long shadow over NASA's human spaceflight program. On February 1, 2003, the Space Shuttle Columbia, having completed a successful scientific mission, was preparing to return to Earth. During Columbia's launch, a piece of foam insulation had broken off from the external tank, striking the leading edge of the shuttle's left wing. While seemingly minor, this impact proved fatal. The foam strike created a breach in the shuttle's thermal protection system, designed to protect it from the intense heat of re-entry. As Columbia descended through the atmosphere, superheated gases penetrated the damaged wing, causing it to disintegrate. The shuttle, now uncontrollable, broke apart over Texas, killing all 7 astronauts on board. The Columbia disaster, much like Challenger, exposed vulnerabilities in NASA's safety culture and decision-making processes. It led to another grounding of the shuttle fleet and a comprehensive review of safety procedures. The Soyuz 1 mission, launched in 1967, is a stark reminder of the human cost of political pressure. Cosmonaut Vladimir Komarov was selected to pilot Soyuz 1, despite known technical issues. Engineers identified over 200 structural issues, but Soviet officials ignored their concerns. Komarov knew the risks, but chose to fly to protect his friend Yuri Gagarin. Soyuz 1 experienced multiple malfunctions, including solar panel and navigation failures. During re-entry, the parachute system failed, causing a fatal crash. Komarov perished, highlighting the dangers of rushing space missions. Chapter 6. The Needle-in Catastrophe, a Secret Tragedy. In the annals of spaceflight history, some tragedies remain shrouded in secrecy for decades. The Needle-in Catastrophe, a horrific launchpad explosion that occurred in the Soviet Union in 1960, is one such event. The disaster, named after Marshal Mitrofan Nedelin, a key figure in the Soviet missile program, unfolded during the development of the R-16 intercontinental ballistic missile, a weapon intended to rival the United States' growing nuclear arsenal. During a routine test on the launch pad, a catastrophic explosion ripped through the R-16 rocket, instantly killing an estimated 100 people, including engineers, technicians, and military personnel present for the test. The exact cause of the explosion remains unclear, but it's believed to have been triggered by a leak of volatile fuel, which ignited upon contact with an electrical system. The Soviet Union, eager to maintain secrecy during the height of the Cold War, suppressed information about the Nedelin catastrophe for decades. The event serves as a chilling reminder of the inherent dangers of rocketry, particularly in the early days of space exploration when safety protocols were often inadequate. Chapter 7. Mars Polar Lander lost in translation. The Mars Polar Lander, launched in 1999, aimed to study the Martian polar region and search for water ice. On December 3, 1999, communication was lost during its descent. Despite extensive search efforts, the lander was declared lost. An investigation revealed a software error likely caused the engines to shut down prematurely. The loss highlighted the complexities of interplanetary missions and the need for robust systems. Chapter 8. SpaceX's Crew Dragon Abort Test, a near-miss and a wake-up call. The pursuit of space exploration is an ongoing endeavor, and even with decades of experience, the risks remain ever-present. SpaceX's Crew Dragon Abort test in 2019 serves as a stark reminder that even the most advanced spacecraft are not immune to failure. The Crew Dragon, designed to ferry astronauts to and from the International Space Station, was undergoing a critical unmanned test flight when disaster nearly struck. During the test, designed to simulate an emergency abort scenario during launch, an anomaly occurred with one of the spacecraft's Super Draco engines. This malfunction triggered an explosion, completely destroying the Crew Dragon capsule being used for the test. Fortunately, no one was on board, and the abort system functioned as designed, propelling the capsule away from the exploding rocket. While the test resulted in the loss of the spacecraft, it underscored the critical importance of rigorous testing and the redundancy built into modern spacecraft escape systems. The incident also highlighted the fact that spaceflight, even in the 21st century, remains a risky endeavor, demanding constant vigilance and a commitment to safety at every stage. Outro: the high cost of discovery. As we've journeyed through these tragic chapters in space exploration history, one thing becomes abundantly clear. The quest to unravel the cosmos's mysteries often comes at a steep price. Each mission, whether a resounding success or a heartbreaking failure, has contributed valuable lessons, pushing the boundaries of our understanding of the cosmos and the limits of human ingenuity. The tragedies we've explored, as painful as they were, have ultimately made space exploration safer. They've forced us to confront our limitations, to refine our technologies, and to prioritize the safety of those who dare to venture beyond Earth's protective embrace. Despite the risks, the spirit of exploration persists. The human drive to reach for the stars, to explore the unknown, and to unravel the universe's grand tapestry is an essential part of what makes us human. As we continue our journey into the cosmos, We carry with us the lessons learned from these tragedies, ensuring that the sacrifices made pave the way for a future filled with remarkable discoveries.